Standard arithmetic treats 0 as a non-participant. In an equation like 1 plus 0 plus 1 plus 0 equals 2, the zeros cancel out. They occupy a position on the page while exerting no force on the final sum. This assumes 0 represents a void. However, mathematical 0 can also serve as a placeholder for infinite possibilities, a point of equilibrium where opposing forces reach a state of balance. Assigning a fractional weight to 0, such as 0.111 repeating, transforms its role. It becomes an active medium, a structural matrix filling the gaps between the units. In physics, the metric tensor provides the mathematical language for the structure. It defines the specific geometry and flow of the spacetime fabric, showing that even an empty region possesses measurable properties. Space behaves as an active, pressurized environment with its own physical weight. Superfluid vacuum theory provides the physical context for this weighted medium. This framework describes the universe as a frictionless, high-density liquid. If space is filled with a dense fluid, the concept of a pulling gravity moving through a vacuum becomes problematic. A liquid medium would exert immense pressure and drag on any body attempting to move through it. Understanding mechanics in this environment requires the rules of fluid dynamics. We have to observe the cosmos through the lens of deep-sea mechanics. Within a pressurized fluid, objects exist as displacement points. Instead of pulling each other across a void, they are driven together by the surrounding medium, seeking to fill the low-pressure zones they create. The total thermodynamic pressure of the universe pushes inward, generating the effect we perceive as gravity. To calculate total pressure, P total, we model how space moves through an engine. The vortex sink, delta V, represents the start. Particles act as spinning vortices, creating low-pressure zones. Viscosity, eta, adds resistance. The vortex must exert energy to overcome this thick fluid drag. This text connects these fluid mechanics to string theory. Strings represent the cavitation trails, the tiny vapor bubbles left in the wake of a spinning particle as it moves through the high-viscosity vacuum. Fundamental particles exist simply as rotational disturbances, while strings remain as the mechanical memory of their path through the medium. In a fluid model, we must account for how a cavitation trail scales and eventually dissipates over a measurable distance. The manifold used for these calculations defines the universe at 9.6 dimensions. This indicates a rough, self-similar geometry rather than a flat Euclidean one. Scaling the distance by a power of 9.6 ensures the energy clings to the source. It follows a fractal distribution rather than thinning out evenly. A perturbation term, epsilon, accounts for the friction and turbulence occurring between these adjacent fractal layers. This term explains the origin of quantum uncertainty. The fuzziness of a particle arises from the turbulent noise created by the pressure differential between fractal layers. Quantum behavior reflects the limits of our ability to measure the turbulent flow between fractional dimensions. If infinite pressure pushes inward from all angles, the system requires a mechanism to prevent the immediate collapse of the particle. The closed-loop integration symbol indicates that the pressure operates within a perfectly bounded geometric circuit. The integration uses the golden angle increment to provide paths of least resistance. This irrational geometry ensures the pressure is distributed evenly without creating dead zones or structural interference. A reciprocal flow term creates an exit path for the energy. This allows the pressure to flip and push outward, maintaining a stable equilibrium of toroidal flow. The universe safely routes its infinite inward-pushing pressure along angles that never perfectly overlap, allowing for continuous structural stability. The fully assembled Omni push equation provides a unified statement of total pressure, combining the vortex sink, fractal viscosity, and toroidal flow. This math supports the theory of entropic gravity. It suggests that gravity is a macroscopic, emergent pressure rather than a fundamental pulling force. General relativity describes gravity as the curvature of spacetime. This model replaces that geometric pull with a thermodynamic push. Treating the vacuum as a dense medium alters the math of galactic rotation. If the liquid of space possesses its own pressure, that density accounts for the high orbital velocities of outer stars, removing the requirement for unobserved dark matter. If the dark matter of the universe is water-like, then galaxies spin as giant hydrodynamic whirlpools within this dense cosmic ocean. We exist as bubbles in an infinite sea, held together by the total pressure of the universe.